Okay, I guess we're on. All right, so as of right now, we have our Nora walking around, and after some period of time, she goes into the battle scene. We kind of drew some squares here to, well, rectangles or whatever, to imitate the thing that they had on Final Fantasy. You know, not maybe that nice, but nice enough. So this guy is our enemy over here, and we're over here. We're going to get to, you know, choose what we're going to do next. There's going to be this like back and forth logic between our fight. I think I asked last time who had played Dungeons and Dragons or something like that. We talked about rolling for initiative. Which initiative is who gets to go first. Kind of you all roll dice and then apply any like modifiers your guy might have to it, and you decide if you're the quickest and can attack the first. So we might want to have some logic like that in here, and maybe initially we'll just decide that Nora goes first. Otherwise, it's going to be a motion back and forth between our enemies and us. And if you were to look at Final Fantasy, what happens when Nora actually makes her move, we're going to be choosing kind of a move here, what we're going to do, either ninja or tase. And at that point, when Nora goes to execute our order, she kind of steps forward. You know, if we're mimicking the Final Fantasy thing, and then does her thing and then steps back. All right, so we're going to kind of create that element. Same thing. And actually, I think that in Final Fantasy, when the enemies attack, they don't actually step forward or anything. They just kind of flash. Because if you remember from everything before, I think we could have like 8 enemies in here on Final Fantasy, so they kind of just have them set up as a grid. So there isn't a guarantee that you have a whole lot of wiggle room to move around or anything like that. So they just kind of flash when the enemy attacks. So we're probably going to have attack scripts for each of these to kind of modularize how we end up doing our attacks. But now initially, when we first come into this scene, we probably, well, right now we're defaulting to just the Kool-Aid Man as our one and only enemy in the games. The whole world is filled with these things. So we probably want him to kind of announce himself, and we have a couple of audio clips. Now, realistically, we want those audio clips to maybe play back to back. So maybe it starts off with, "Oh yeah." That's kind of how he announces himself, right? It would make sense. That's a very terrifying type. Who wouldn't walk into a room and you see a Kool-Aid Man with a machine gun and be, I mean, you really see anybody with a machine gun, but specifically a Kool-Aid Man with a machine gun, and you become very nervous very quickly. Right, Brennan?
Exactly.
That haunts his dreams. All right, so let me download these couple of audio clips so we can bring them into our, I'll just put them in downloads for right now. And we're going to bring those into our game. And then what we want to do is we want to figure out how to have audio play back to back. We certainly don't want both clips to play at the same time, right? You know, that would maybe be terrifying as well, because he's kind of yelling and shooting. That actually might work out okay, but you know, let's go back to back because we want to be able to kind of detect when audio clips end, and maybe that's an event that triggers us to do something else. Okay, so I'm going to go ahead and let's create a folder here for sounds, just so we can kind of compartmentalize these things. So I'll go into that folder. I'm going to right click, and we're going to import new asset. I'll go to my downloads folder. And here's my Oh Yeah clip. And here is my machine gun clip. I'll import those. Okay, so now I have those couple of clips that play. All right, so what we're going to do is let's actually close this. So let's get into our second scene. So that's going to be our fight scene. All right, so here's our Kool-Aid man down here. All right, so he's our actual game object that we want to attach some stuff to. So we're going to teach him specifically how to do these couple of sounds, or he's going to actually hold those components, those sound components. Similarly, and we want to kind of think about this a little bit. In a game, we might have 20 different kinds of enemies. Something like that. Now, what you can do is you can create each enemy individually, where each one kind of has their own sounds, their own this, that, or the next thing, and really have those enemies be very rigid on how they work as individuals. Or we can make them more modular, where we attach maybe kind of an enemy script to anything that's an enemy. Maybe we could let that script know about any audio clips that he should play. And then he actually goes and plays those audio clips when he comes into existence or something like that. So we probably want to move in a more generic manner. So let's first do kind of a hard-coded version and then move to a generic version so that we can apply it to a second kind of enemy. That way, adding new enemies to our game isn't this whole kind of maybe a custom task. All right, but for now, I'm going to drag the oh yeah sound. Oh, I'm still on sounds here. I got to click on my Kool-Aid man. So I'll drag the oh yeah sound over here. And then I'm going to drag the machine. Oh, hold on. I need to. Oh, we only have one audio clip associated with him anyways. Let's just do oh yeah for right now. And we'll go ahead and say play on awake. Now that should be good enough, at least for just an initial test. Oh yeah. It's actually interesting. Hold on. Oh yeah. Did play both. Why did it play both? I'm going to dump this audio source initially. Just make sure it does. Oh, I got to do that again. Oh, yeah. Oh, it's because I have this thing in the scene. All right. I don't want to have sounds just in the scene. So I'm going to attach the oh yeah thing to our machine gun dude. Oh, that puts it into the scene. It's just a separate thing. We can't attach it to a... Oh, I'm not attaching it to the Kool-Aid man. Should actually read my game objects here. I want to attach it to the Kool-Aid man. So we'll then do the oh yeah thing here. No, it still adds it to the scene. We can't attach an audio source directly to... We do add. We have to do the directly add component. We can't drag or drop it on there. So here's an audio source, and then we'll attach the clip there. We'll tell it to play on awake. Now it's attached to the, although it's still put it out here. Or was that left over from before? Probably left over. Because it didn't put it out there on my... Oh, yeah. Okay. And it's not going to let us add a second audio source. Or at least I think it's going to give us an error if we try to run this, because it's going to say it found two audio. Oh, yeah. Maybe not. So this should play them both on top of each other. Oh, All right, so let's have two audio sources. So let's go ahead and we're going to, actually it's going to be interesting. How do we differentiate these audio sources from each other? Because the second one, maybe we have this guy not set on play on awake and this guy not set on play on awake, but we actually are going to have programmatically two different audio source components. So let's see how we can grab individual audio source components. Do we have a script attached to our enemy here? We don't, so let's go ahead and let's make a script for this guy. And we're just going to, for right now, let's just call it enemy script, or just enemy. And we're going to go ahead and we're going to create a couple of variables for our audio sources and then see if we can differentiate between the two. All right, so we'll go ahead and create a private variable. This guy's going to be an audio source. Let's call it odd one. And then we want a second audio source. We called odd 2. And then we'll say this dot odd 1 is equal to this dot get component. Audio source. That's going to be very interesting. Is it going to get confused? It's going to say it found two audio sources. Let me attach this to that object. This isn't going to be the way we do it anyways, so I don't want to go too far down this path. But let's attach this guy to our Kool-Aid man. All right, so now on start, he's going to try to grab the audio source from this, but it's going to find that he has two different audio sources. Okay, well, I got one of them. Let me just print that out. What if I try to grab the second one? Will it grab them in order? Like on multiple requests? I would doubt that's going to do what we want it to do. Let's see if we get memory addresses for these guys, or that's actually probably not going to make a difference because we want to see what the component under the hood is. But let's see what this guy ends up looking like when we run it. All right, so it got two different audio. Well, it got two audio sources, but I suspect that they're both the same audio source. Can we get a? I think we would probably have to do this. This dot get component, and there's a get components with this, so we can say get the audio source components. So let's see what this guy returns again. He returns a component array. So we're going to say component array odds is equal to what that guy returns. And we actually could probably say this is a component array of audio sources. Is he going to be cool with that? No, he doesn't like us casting it. That's okay. We just know there'll be audio sources in there. All right, so we're going to store all the audio source components we find inside of this component array. Then we'll go ahead and say this dot odd1 is equal to odds at bucket 0. This dot odd2 is equal to odds at bucket 1, and those guys are coming out as generic components. So we need to typecast them to audio sources. Okay. And then for right now, let's just go ahead and say this dot odd1 dot play. Let's just make sure that, well, yeah, let's make sure just that guy plays, and then we'll grab audio 2. Otherwise, we play them on top of each other, we won't know who's who. Let's just confirm that we're getting the 2 different guys. This is probably not the best programming practice, especially for writing this to be generic. But for our test, since this isn't the way we're going to do it anyways, we know there's 2. All right, so we'll just make that assumption. All right, so my feeling is it's probably going to find this one first, so it's probably going to play the oh yeah initially.
Oh yeah.
Okay, and then if we instead tell it to play audio 2, then it should do the machine gun sound this time. All right, so we're grabbing our 2 separate audio components. Well, now we want to have logic where we really want it to do, oh yeah, but as soon as that guy finishes playing, we want to run the other one, right? So let's look at what things we can do with audio sources. Let's just stop this one for right now. So this dot odd1 dot do we have a that's the position and time. I think there's a way we can get the amount of time that would be the easiest. Otherwise, we're going to have to ask if it's currently playing. So let's just go to documentation here. And we'll do Unity audio source. Just do a search for length. Audio clip length. But is that coming from audio source? Okay, it's audio source dot clip. Okay, so that's the actual clip. That's the length of the clip in seconds. So I'm going to go ahead and say float length of odd1 is equal to that guy. Then we're going to go ahead and we're going to say this dot odd1 dot play. And we'll say this dot odd2 dot play delayed length of odd1. Something like that. All right, so this guy's going to hold off for length of odd1 number of seconds, and while odd1 is currently playing,
oh yeah.
Okay, a little bit of a delay because the clip probably said oh yeah and then had some white noise at the end or whatever. So we can leave it at that. It seemed to be pretty accurate enough, right? We can probably shorten our audio clips. We can certainly, if we're writing this, we can just go to an audio mixer and glue the 2 audio clips together and play one clip. Probably the better way of doing it, but from our perspective, programmatically, if we have multiple clips that we want to play in a certain order, this is the game we would play. So let's keep working with this kind of version of it. Okay, so we have this guy kind of playing some sounds. Now, what I'm going to do here is I'm going to show an alternate way of doing this. So we're going to say odd1.play. And then inside of update, we're going to ask the question, if this dot odd1 dot is playing, and we're going to say if it's not playing, sorry. So if it's currently not playing, we want to go ahead and kick on audio 2. But this will start audio 2 playing every single time we hit an update that it's not playing. So we need to have a way of flagging that we've played audio 2. So we'll create a private bool odd2. Let's call it odd2 fired or something like that. And this will start off as false. Okay, and then we're going to go ahead and say if odd1 is not playing and not this dot odd2 fired. If both of those are true, then we want to go ahead and say this dot odd2 fired is equal to true, and this dot odd2 dot play. So we'll start off audio 1 playing, then on update we'll keep asking the question, is audio 1 still playing? And or is it done playing? That's what this asks. Is it not currently playing? So is it done playing, and have we not fired audio 2 at this point? If those two things are true, then we'll go ahead and fire audio 2 and actually play audio 2. So this doesn't happen multiple times. We'll still be asking this question every single time through. So that's a performance delay, but you know, for us, it's not going to hurt us too terribly much. All right, so now we should get a pretty similar type of experience from this.
Oh, yeah.
All right, so pretty much did the same thing as I did before, just it accomplished it in a different way. Which of those two ways do you think is better from a performance perspective?
Doing it in start.
So doing it in start, we're just kind of setting everything up for the delays, right? And building up. Now, what if we had a whole bunch of audio clips? Because right now we're getting this, this audio set of audio sources, right? And we know each of those is audio clips, but we don't necessarily know how many audio clips. What if we wanted to rate it more generically? So odds could be anywhere between 1 and 50, let's say. If you had a really, really chatty enemy, okay. One of those guys that has the whole, the monologues where they come in, it's got the whole back and, there's all the enemies in the movies. That's what they do, right? They talk too much. Because that's when the good guys, they decide to shoot them while they're in their monologue. It's just a superhero movie. All right, so if we want to write it more generically like that. All right, so what I want to do is I'm going to have this collection of audio clips here. And I want these audio clips to play in the order in which I'm getting them. It seems like that is kind of a requirement, let's say, that it's, we have to put those components in there in the right order. But still, this isn't the way we're going to ultimately end up doing this, so we'll just make that assumption. But we don't necessarily know how many audio clips we've put in here at this point. We just know that we have a bunch of audio clips. And I want to play them in order, but with the correct offsets. So how would you go about doing that? Go ahead.
You can make a for loop every time there's something next to you increment. Yeah.
Okay, what am I incrementing?
You'll have a number keeping track of how long one that's playing is going.
Yeah. So we'll increment it. We'll not just directly increment. We'll extend the delay. So we're going to keep track of total delay, right? So we'll have a variable type float. Maybe call this guy delay, and it'll start off as 0.0. It's actually going to make me put an F at the end of it. That's so dumb. It's very interesting. Although, I mean, I guess it makes sense. But, historically, we came from these older languages like C. And in C, we had floats and we had doubles, right? And that was more from our memory saving perspective. Well, so when you created something that was a float and you created something that was a double, the types of values you put in there were identical. You just had different limitations. A float can only hold a value of this size. A double could hold a value of this size. Well, now what they want to do is they want us to say, look, if you're going to create a float, make sure you informed us that this guy is a float, rather than putting the limitation on the, I guess it would be the linker, but I don't know, that seems weird. We'd have to do that. Can't it just trust us? Like, look, I said it was a float. It's a strongly typed language. It's a float. Roll with it. If I give you bad values, you'll scream at me, just like if I say int A is equal to 7 billion. It's going to scream at me. It's too big. Poor design. It's just garbage. All right. But this is not the only language that does it. In fact, most modern languages, so there's probably some sort of performance benefit. Or it's actually probably how they're represented under the hood. They probably represent floats and doubles using one, so kind of a similar thing to what we're accomplishing here, using one construct and then treat it by different rules depending on how you're, what you flag the value as. I'm not sure where the F requirement falls in there, but we'll give them the benefit of the doubt and say maybe there's a reason, since there's more than one language that does this. So it's probably, it would be funny unless it's just they copied some mistake. Like some guy in I don't remember where this first was introduced. It might have been C#. So I don't think C++ makes you put an F. It might, actually. That'd be funny. And so they just make this like kind of this weird decision then, and then just everybody's copying it forever and ever. I guess that's funny to programming language people. That's not entertaining, Brennan. Just a little bit, just right on the borderline. All right. So we'll have our delay, and this is going to be a built-up value, and then we're going to go through all of our components. So we have a for each in here, don't we? Yeah. So for each, is that the syntax for it? Now let's just look at syntax for each. We want to say for each audio clip in odds. C# for each. Just give me an example. For each loop examples. For each string value in Pascal. Okay. So this is going to be for each audio clip. It's audio source, right? Each audio source. You can call it whatever you want, but AS is going to be here. We'll call it odd. Audio source in odds. Do something. So we can, I spelled it wrong. There we go. Now it's happier. Now we can certainly write a normal for loop, for int I is equal to 0, I is less than odds dot length, I plus plus. Or since we don't need the actual index here, we could just say, hey, go through all the audio sources in odds and let me do something for each one. And what we'll do is we'll play each audio source delayed by delay number of seconds. So the first one will play a delayed of 0 seconds, right? So we'll say odd dot play delayed delay, and then we'll say delay plus equals odd dot clip dot length. So that'll build up our delay. So the first delay will be 0, so we'll play the first audio clip with a delay of 0. The second one will be 0 plus whatever the length of the first clip was, so on and so forth. So you should play them all back to back to back to back, regardless of how many audio clips we have. In theory.
Oh yeah.
Second here. I'm going to take this logic out of here. Take our, we don't actually need audio 1, audio 2 anymore. So now we're just doing everything generically.
Oh yeah.
All right, so went through our list of audio clips. In this case, we only had 2. If we wanted to throw in another audio clip just to test this, we'll go ahead and add another audio source. And because he really, really, really likes saying, oh yeah, we'll throw the oh yeah in there for that last audio source. So now it should do, I hate when I do that. So I got to add this again because the game was running. All right, so there's that guy. Here's our oh yeah for that guy. So now it should do oh yeah, machine gun, oh yeah.
Oh yeah.
Oh, hold on. We already burned that guy. Does that mean it wouldn't have played it a second time? Because I think the 2 oh yeahs played at the same time. Did it again.
Oh yeah. Oh yeah.
That's interesting. So once an audio source is played, it would have to be reset in order to play it again. So we'd already burned past it because we had it play at the start. So they both played. The 2 oh yeahs played on top of each other. And then when it went to play it again, it was already exhausted. It couldn't, there was nothing more to play. So this guy's doing that relatively generically, but we would say that this is pretty inconvenient, right? Having just, every time you want to have it play a sound, have it throw this audio source in there. So if we want to make it more generic, I mean, this is somewhat generic, except what we need to do is for each of our enemies that, we'll have a game object for our enemy. So for each of those, we have to drop in a whole separate audio source for each of our dudes. That might become somewhat of a hassle, something like that, but not a big deal. Especially, but if you're going to have 50 clips, scrolling is going to be a problem. So what's an alternative solution to this? I think we've done this in here. I want to do a very similar programming logic behind the scenes, but rather than grab multiple audio sources, I want to be able to provide the clips to a script in the order in which we want them to play. Have we done something in here where we've provided more than one value in a single variable? Okay, well, so let's look at it. So I'm going to go ahead and we'll create a public variable here, and public exposes it to Unity, right? And what we want to do is we want to have an array of, in this case, what we want is an array of audio, clips that I want it to play. So this is going to be audio clip array, and we'll call this guy odds. Okay, let's just stop it at that guy right there. So now we're going to go back out here to Unity. And let me just dump all my audio sources for right now. We're going to have to add one back in. Okay, so notice I have this thing called odds right here. And for this particular dude, just so we can kind of keep it with our 3-element thing, I'm going to say we're going to have 3 audio clips that I want him to play. All right, so now I have little buckets here. So this allows us to visually create an array. All right, so I have little buckets here that I can now drop my audio clips into it. So I'm going to say I want it to say, oh yeah, first. Then I want it to do the machine gun sound. Then I want it to do oh yeah again. So right off the bat, definitely more convenient, right? Okay, so now in order to play something though, we are going to need an audio source. So I'm going to go ahead and we're going to add an audio source here. And we'll turn off play on awake because I'm not going to associate a clip with this guy yet. All right, so because I don't think we can tell a clip to play itself. Let me just confirm that real quick. Odd.clip. Yeah, we need an audio source to play the clip. Okay. So we'll need a blank audio source that is capable of playing a clip for this guy, but just one of them. And then what we're going to have to do is we're going to have to keep updating which clip we want him to play each time through. Does that make sense? All right. Now, it's just going to be kind of interesting here. I wonder, can we repurpose an audio source and do a play delay? Like, can I set its clip to something and play delay 0.0, and then set its clip to something else and do a play delay at something else? Or when we switch the clip, is it going to play the original thing? It's going to be interesting. So we have to see how this, we just went to Home Depot, we got this tool, we got to see how the tool works now, and then we'll modify our solution based on how it works. All right, so I have an array of clips, and I have my one audio source that I'm going to use to play those guys. So I will need to go ahead and get my, just in case we're going to need it in a different place, I'll create a private audio source, odd. Let's call it odd S. I'm just avoiding calling it AS because that would be, I guess, funny. Okay. Okay, so now we're going to do for each audio clip in odds. Well, it's actually, these are going to be confusing. We have odds and odd S. Technically, those are different variable names. Just in the most confusing way. So we'll just call this audio source. Just bite the bullet, right? And here we'll call these odds is fine there. All right, so this is going to be audio source. We'll just really spell it out. All right, so for each audio clip, odd in our odds, we want to go ahead and set our audio source's clip to that guy. So audio source dot clip is equal to odd. Then we're going to go ahead and say audio source dot play delayed delay. And then we'll add to our delay the length of our clip, odd. Now, my hope is that when we say play delayed, what this does is it kind of queues up the clip to play at a certain period of time, which would then free me up for the next time through this loop to adjust my audio source's clip to a new clip and then schedule that next clip. It's possible it's not going to let me do that. It's possible it's going to require the audio source to finish playing the current clip before it allows me to change the clip. All right, so we have to look at how this tool actually functions, which will give us a little information of how it's working under the hood. Really, it'll tell us how play delayed works. So in theory, this guy should go through every one of my audio clips, again, keeping track of our delay, set our audio source to that clip, although I'm never actually grabbing my audio source here. So I have to say this dot audio source is equal to this dot get component audio source. And we're okay doing that because we know we've only added one audio source to this guy. So we'll grab our audio source, then start a delay off at 0, then go through all of our audio clips here. For each one, we'll set our audio source's clip to that guy, then play that guy on a delay equal to the current value of delay, then update delay. Spin back through, update audio source's clip, try to play it on a delay again, and we'll probably see pretty quickly whether or not we have, I guess what would probably end up happening might be a race condition. Oh, this might be... Let me just do this for a moment. I'm going to change this guy to be just 2. So we'll do oh yeah and machine gun. Otherwise, we potentially wouldn't have known if something bad had happened, because I think the real risk is that the clip it actually plays is the very last clip. Because if it works in the way that I'm hoping it, if it works in the way that I'm predicting it does work, but I'm hoping it doesn't work that way, the clip it will end up playing first will be the very last clip. And if we had oh yeah as the first and the last clip, we would be tricked into thinking it worked until it didn't play the next one, I suppose. So let's go ahead and attempt this guy. So we have 2 clips, oh yeah and machine gun. So the first time through, we'll set our audio source to this clip, play it on a delay of 0. Next time through, we'll set our audio source to this clip, play it on a delay of whatever, 2.4 or something like that. And we hope they play in that order. We hope that that delay becomes a scheduled type of thing that happens in the future and doesn't rely on the audio source to have the same clip set for it. So let's see. Yeah. So my prediction and my worst fears came true. So the audio source at the time of playing does need to be the current clip for that audio source. All right. So what that means for us is we're not going to be able to kind of pre-stage, plan when these guys are going to play. So we need an alternate algorithm for this particular approach. Not a big deal, hopefully. So we're going to come in here. Now, let me try something. Can I create a new audio source? I just want to try, I think this might still be a problem. So we're going to say audio source a source, and then in here we'll say a source is equal to a new audio source, and then we'll say a source dot clip is that audio, then a source dot play delayed on that delay. So in this case, rather than relying on the audio source component we added to it, we're going to try to generate a brand new audio source each time through this loop and attach a clip to it. So we actually are not going to be replacing the clip on each audio source. But does this audio source need to ultimately be part of the scene in order for it to work? I guess we're going to find out. So we probably need to add that component. Now, we could do this, So we might not be completely screwed here. So then after we create that audio source, we would say this dot, let's get component. I can't add a component at runtime. Unity add component at runtime. Game object add component. Oh, so we got to do it to the actual game object, not to the script. That makes sense. So this dot is the script itself. This dot game object is the underlying game object to which we want to add the component of type audio source. You might not have had to tell it the type. In fact, I doubt we needed to tell it the type. So we're going to add a component, and it wants the. What is this? Does this guy return something? That's the component type. Can we actually tell it the? Well, I don't like that at all. So that doing it this way, we would not be able to create an audio source. We would have to create the component, then request the component from it. Because add component does not return for us the component that we added. Oh, no, it does. It gives us that component. We just don't create a new audio source each time, so that's fine. So we won't do this. So instead, we'll say this dot game object dot add component of type audio source. So it'll give us a brand new audio source component, and then that will return it to us, and we'll store it inside of a source. Then we'll set a source as clip, play it on delayed, update delayed. Next time through, we'll add another audio source to this guy. We'll store it in a source just for us to work with it, but this is a unique audio source to the previous one. Okay, so this should work as is, I believe.
Oh, yeah.
All right, so that gets us a reasonable thing, and we can actually then delete our initial audio source thing. So we're doing a majority of it programmatically. So now from an enemy design perspective, this is pretty clean, right? You know, basically you just fill in the number of sounds you want this guy to play, and it'll play those sounds. Under the hood, if we watch this during runtime, though, we'll see that some extra components get added to this guy. We're going to see 2 new audio sources get added in here.
Oh, yeah.
There's the first audio source. There's the second audio source. We're actually seeing the game running. So it physically added those audio sources to this game object. All right, if we add a third thing here, we want to say, oh, yeah, the last time. We'll drag oh, yeah in. And I have to redo all that because the game is currently playing. So I like to practice. So now I'm just making that one change.
Yeah. Oh, yeah.
Okay, so that's actually not really a bad approach. I don't know if there's a horrible negative downside to adding audio clips to a game object. Probably not horrible would be my guess, especially since they're done playing. I'm guessing the resource is probably I mean, if we really wanted to let's see, we can do a an invoke. So I'm going to do void remove source. I'll make this private. Oh, that wasn't what I wanted to accomplish. So we're going to attempt to clean up our own mess here, which we never do. Audio source. Let's call this guy source. And then we'll do this dot game object dot I guess we'll probably, instead of removing it, I think we'll just have to turn it off. Maybe source dot enabled is equal to false. So let's try that first. So this is going to be a function that will call, passing it an audio source, telling it to have that audio source turn itself off. And how do we call a function in some delayed amount of time? Using invoke. So we'll go ahead and say invoke. The name of the method is remove source. Ooh, can't I pass invoke? I think I thought I could pass it one parameter. This might not do what we need it to do. There's something called a coroutine, but a coroutine doesn't allow us to do a delay. It's getting pretty sloppy. we can keep track of an array of audio sources up top, and as well as a current pause. And then every single time this function gets called, since he's not going to be able to take a parameter, he would then go grab the appropriate audio source from that array based on pause, disable it, and then increment pause. So for the next time he gets called, it would be a different audio source. I mean, at this point, this is becoming funny, I suppose. But that would work because it appears like I cannot call a future. That can't be right. So Unity invoke with parameters. All right, workaround for using invoke with parameters. Let's look at the Unity forum thing. Yeah, here's the coroutine thing. Oh, so you'd have to start your coroutine, but tell it to yield for a period of time. But now how do you get the timer in there? Oh, you can pass it as a second parameter. Oh, we got this. All right, so we're gonna introduce a coroutine thing here. All just to clean up. This is why we don't clean our rooms at home. This is inefficient. All right. Yeah. So just so we understand here, what we're attempting to do is make sure at the end all of these audio sources are disabled. We should see the little check boxes go away there. With the idea that they won't be bogging down our game object if we removed them from the scene. I do not see well, we'll look secondarily since we're going down this dark path. But I don't think there's a way to directly remove a component from a game object. But let's do this coroutine thing because it looked fun. So we're gonna create our function. We've already got that, and this guy is going to have two parameters. We're going to have the audio source that we want to get rid of. Why does it say function? Does a coroutine need to be a function like this? Because we can't get a. Oh, yeah, he's doing it in JavaScript just because. All right, so we're going to take in a. In any case, we'll take in our two parameters. So we might have to update the syntax for our coroutine, but whatever. So we'll take in two parameters. One is going to be the audio source we want to disable. The other one will be how much time until we disable it. And I believe a coroutine will run in its own thread. So it'll run as non-blocking. So it's not going to wait 3 seconds and just stall the entire game while this is happening. So we'll go into our code here, and remove source is going to be our audio source, and then we're going to say float delay, and then we're going to wait let's see if that was a yield. Wait for seconds. Okay, this guy uses scaled time versus unscaled time. I wonder what the difference is. I bet you the difference is that scaled time operates off your previous coroutine call. So you can probably then always pass it in the clip length instead of the accumulated delay that we're building. Whereas unscaled would be the total delay that we want it to wait. So we've been calculating an unscaled value. That would be my understanding of this. So let's test it with that. So we're going to use wait 4 seconds real time. And the seconds is going to be our delay. And can't be used as a method. Wait 4 seconds, real time.
You have to do the yield and then.
You have to do it before that?
Yeah. The yield and then it looks like the C# you need to do return new. Wait.
Like that?
Mm-hmm.
Do we actually have to return? Seems weird. Maybe that's how the yield function works. Or the yield keyword, rather. All right, so wait 4 seconds delay. So we'll start this coroutine. What's this guy complaining about? Oh, because it... so this guy's returning an iterator interface type. Well, we definitely can't return there because that's going to end the function. Wait 4 seconds, real time. Yeah, it's doing. Oh, it's having a return an I enumerator. We're not going to use this I enumerator. That's just what this wait 4 seconds real time returns, but it still allows us to get to this dude. So we will remove the source. Which source? This guy after this amount of time. The very first thing we'll do is we'll wait for that amount of time and disable the source that we passed in. And then what we need to do up here is we need to start a coroutine. Which coroutine? We're going to call remove source, passing it our a source and passing it our delay. But we need to do that before we update delay for the next. No, it's going to be it's this one plus the length. So we update the delay first. Yeah, so this is the amount of time until this guy should be removed. Then start the coroutine, remove the source. Which source? The source we just created and added to our game object with this delay. And it'll call this guy in its own thread. So non-blocking, it calls it asynchronously. Those are all kind of synonymous with each other. So it doesn't, the big issue with that for us is we want to make sure that this line right here doesn't cause us to not get to the next iteration of our for each loop. So if this guy did something called block, if he blocked, we would not get to the next loop through our for each. If he's asynchronous, if he's non-blocking, that means that this coroutine is running at the same time as our for loop is running. So when this guy's doing his thing or pausing, it's not preventing us from moving on over here. All right, and that's how coroutines work to begin with. That's the point of a coroutine, is having two things happen at the same time. Invoke, my guess is invoke does use a coroutine, but it must be kind of a special. I'm surprised that it doesn't give you the functionality to pass it parameters. But it must be that they actually, that invoke must work differently. You must not use the coroutine subsystem, so it might not necessarily create more threads. It might just have a single thread for handling all invokes, and it just handles them in the order in which they were called. So with that in mind, it's possible that if you have two functions, if you call the same function twice with invoke, and let's say you're going to delay 2 seconds, but inside of that function you wait 20 seconds, that second invoke will not actually happen until 22 seconds in, even though you said delay 2 seconds, because it would have to wait for the first invoked function to finish. That's possible how that guy works. We can certainly test it, but let's test this. Let's just do this. All right, so we're going to create a new audio clip just like we did before. Already saw it work, but then we're going to try to clean up our room. So we're going to start a coroutine, passing it the source we want to disable, the amount of time until we want to disable it. This coroutine will get called immediately, but then he'll go to sleep for an amount of time, and then finally when he wakes up, he'll disable the source. That's what we're hoping happens there. All right, so we should see the 3 different audio sources show up here, and when we're done, we should see check marks come off.
Oh yeah. Oh yeah.
And we've cleaned up our room. Can we actually remove a component? Unity game object, remove component at runtime. Oh, we could tell it to destroy itself? Well, that could be fun. So instead of setting it to disabled, can we say source.destroy, or is it, No, it's destroy. Source. All right, let's try that. So instead of disabling it, let's just try to destroy it. We don't need it anymore.
Oh yeah. Oh yeah.
Yeah. Best way to clean your room is to burn all the clothes. Okay. This is fun, right? This is the most time I've spent cleaning up a mess just in years. All right, so create a bunch of audio sources, play them on a delay, clean them up with a coroutine at the end. So several new things there. All right, so we have our dude who has now started, well, Kool-Aid Man has introduced himself at this point. All right, so now the next thing we'd like to see happen is we want to see, we already have the option here for Ninja or Tase. Okay, and for right now, let's say it doesn't matter which of those two options you choose. But, and actually let me go ahead and put this in a assignment. And then I'll paste the script we did today up. There we go. Content. All right, this is assignment 6. All right, so allow Nora to select an attack type and then have her move forward let's just say for 2 seconds and then move back. You do not have to actually well, you should do a attack type thing. Well, let's just do that in class on Tuesday. You do not have to actually make her attack or make Kool-Aid get hurt. So we're responding to, and maybe when you select an attack type, maybe you say by pressing enter. If you want to do it with a different button, that's fine. But you select your attack type, you press enter. Nora then steps forward, pauses for 2 seconds, steps back. That will indicate that she has performed her thing. Make sense? All right, so that's your assignment for Tuesday. What I'm going to do is, because I was sick earlier in the week, I'm going to put up a Bible assignment for, I'll put it up today. And what I'll do is I'll make it due like midnight Sunday or something like that, just to give you more time, and then we'll have our final one next week. I'll maybe put up both now while I'm thinking about it. So one of them will be due midnight Sunday, and then the other one will be due the end of next week or Thursday of next week, whatever. Sound good?
What will you talk about?
Final, we'll talk about, well, we might talk about it on Tuesday, but we'll definitely talk about it on Thursday. But what ultimately what the final is going to be is I'm going to give you our game here as a starting point, and then have you add a feature to it for the final. But I'll give you my starting point for it, so everybody will start with the same game instead of you relying on your thing. Make sense? But that'll be what it is. But we'll talk about possible type things you might have to do for it on probably on Thursday. All right. I will see everybody on Tuesday.